is the degree, the difference, or the angle between these 2 points. To determine the angle between these 2 points, you simply use theta equals tan inverse y over x. That is, you're simply substituting the y value or the y component, and you're substituting the x component respectively where needed. Now let's quickly look at some examples here under gradients so we can fully understand the concept of gradients and how to solve questions associated with them. We have 2 examples here. The first example says find the gradient of the line passing through points 2, 3 and 4, 5 and the angle of inclination. Now your gradient formula is simply y2 minus y1 over x2 minus x1. But before then, the first thing you want to do is to label your points. x1 to be 2, y1 to be 3, x2 to be 4 and y2 to be 5. Labeling it this way aids you to substitute them quickly and you get your answer. Now substituting y2 5, y1 3, x2 4 and x1 to be 2, you get your gradient to be 1. Now we also asked to find the angle of inclination, and if you've been following, angle of inclination is simply theta equals tan inverse of y over x, and y over x is simply the same thing as your gradient, which is m. So we can simply say theta is tan inverse of the gradient, and the gradient here is 1, so shift tan 1 gives us the angle of inclination between those 2 points to be what? 45 degrees. Let's quickly look at the second example. You might want to pause the video and try this out yourself. Find the gradient and angle of inclination of the line passing through points 0, 1 and 3, 7. So first thing is label your points. Always do that. x1, y1, x2, y2. Substituting your values, you get the gradient to be 2. And theta equals tan inverse of m, which is your gradient. So if you do your tan inverse 2, you get the angle of inclination between the 2 points 0, 1 and 3, 7 to be 63.43 degrees respectively. Now let's move further. The next thing we want to look at is the equation of a straight line. The equation of a straight line. The equation of a straight line can be represented in several forms. In the earlier part of this video, I showed you 2 equations of a straight line. Now we have about 4 different types of it. The most basic form is the point slope form, where you have your arbitrary points x1, y1. So this is a point slope form where you have your y minus y1. We're going to be using this a lot, and you expect it to be more conversant with this. In fact, all of them. So when you talk about the slope intercept form, y equals mc, mx plus c, that's when there's an intercept. We also have where the line crosses the origin. Now in this case, there is no intercept, right? Intercept is 0, which is y equals mx plus 0, which is y equals mx. So in that case, we present the equation of a straight line to be y equals mx. Now one major thing about a straight line is it is a linear equation and also an equation of first degree. When you see a square on an equation, you know that that equation cannot be a straight line, right? Now you have a general form. The general form of a straight line is represented to be ax plus by plus c equals 0, where a, b, c are constant, right? So you have these 4 major forms of representing equation of a straight line, and I say the most